This week we're going to look at one function argument that can reduce the data your space take up on your disk by up to 5 times. Welcome to another MetPy Monday. Hello, I'm John Lehman, a software engineer for Unidata. This week I wanted to show you one very handy function argument in Pandas that I didn't know about until recently that can save you a massive amount of disk space and just a couple of lines of code as well. So to start out with, we're going to need some data. I'm going to use Mesonet data as my example. So I've got a URL here for the Miami station from today. And now we're going to read that in. We've talked about reading Mesonet data in past MetPy Mondays, but the brief summary is we're going to pass the URL directly into read CSV, and it's going to go get that for us. We're going to skip the 2 header rows, and then for delimiter, this is a little bit different, where it's not strictly tab or comma delimited, it's space delimited. And the best way to do that is to say this is a raw string of any number of space characters. And now if we look at the head of that data frame, you see you've got our station ID, station name, time, relative humidity, air temperature, wind speed, and so on, all there. If you do want to see all of the columns, of course, you can look at df.columns. Now, this is not a terribly huge amount of data, but it could be something much bigger. Or instead of one day, maybe we've concatenated together something like 50 days worth of data. And we don't want to have this huge file sitting around on our disk. Let's say we've done our processing and we're ready to write this back out. So I'm going to write out a CSV file. Everybody's favorite, the Excel file. Which of course you might have to install the Excel package in Python. If you don't have that already installed, you might get an error message there. The web's favorite format, JSON. And then finally, a pickle, which is a compressed format in itself, though not necessarily recommended for long-term storage. Now here comes the magic part. In the past, I've written things out as CSV or JSON, and then using a different utility compressed them. But did you know Pandas can do that for you? So I'm going to use gzip compression. For my toCSV and for my JSON. Now, depending on what operating system you're on, I'm going to use some notebook magic here to look at the files in this directory that start with the name data. So this would be something like ls-ltr or something similar if you're on a Linux machine. But here I'm on Windows, and we can see that here's my CSV and my CSV gzipped file. Now, since a lot of the values in these time series are going to be very close together, the file compresses quite well. In fact, if we look at the ratio for the CSV, it compresses by nearly 5.7 times. And if we look at the JSON, we're going to see that it compresses quite well as well, about 4.5 times, though not as good as the CSV, and the JSON file is significantly bigger just because there's a lot more structure around it. The pickle file is also actually a decent size, as is Excel. So a gzipped CSV turns out to be a great way to store this sort of tabular data. Again, this is a really simple tip, and there are different types of compression that you can find in the documentation. Of course, so if you just go up into the function and do a Shift Tab and go down to compression, you can read more in the detailed doc string. So we can infer gzip, bz2, zip, or xz. Now, I thought this was a very useful thing that eliminated several lines of code and made more efficient use of my disk space, which with SSDs is always an issue. I hope that you found this tip useful, and I'll see you on next week's MetPy Monday.